All right, you guys, I wanted to review just one problem looking at sampling distributions for proportions. So before I even start, what I want you to imagine is a whole bunch of statistics gathered. And when we put them all together, we can see a beautiful bell-shaped curve emerge. So we're saying, okay, the distribution would look pretty normal with our true parameter right smack in the middle of it. And right now we are working under the assumption that we do know the true parameter and we know our sample size as well. So let's go over this problem. So Harley-Davidson motorcycles make up 14% of all motorcycles registered in the US. You plan to interview an SRS of 500 motorcycle owners. You may assume that the three assumptions have been met and the distribution is approximately normal. So what is it giving us here? That 14%, right? It's telling us the true parameter. So here we know the true parameter. We know the P. Okay, we also know our sample size, the N, is 500. Okay, so let me just write these numbers down. N is 500, the P value is 0.14, the Q value is 0.86. Okay, so the mean would be just 0.14, right? It's the 14% of all motorcycles registered that are Harleys. So we're saying we're building a distribution around that information. Okay, standard deviation. So we're looking at P times Q. So 0.14 times 0.86 divided by the sample size of 500 and then taking the square root. So that's going to give me a standard deviation of 0.0155. Okay, so I have an indication of the mean, the average, and the variability that goes with it. So now the question is saying, calculate the probability that more than 20% of motorcycle owners in the sample own Harleys. Does this seem unusual? Why or why not? So what I want to visualize is a normal curve. My mean, right smack in the middle, is that parameter that we were given initially. So right here, we're looking at that 0.14, that 14%. So we're assuming that 14% of all motorcycles registered are Harleys. Okay, and we're saying, well, what would be the likelihood that more than 20% of motorcycle owners in the sample own Harleys? So we're saying, okay, we're working under this assumption, 14% own Harleys. What if it was 20% instead? And specifically, more than 20% own Harleys. How unusual would that be? What is the probability for this scenario right here playing out? So here, I'm trying to capture the area under my curve, and I'm just expressing that as a probability. So remember that over here is my infinity, and I need a placeholder for my infinity. I have not converted to z-scores, so I can base it off of my raw data. So I can say normal CDF from 0.2, from here, 0.2 up to infinity. What's my placeholder for infinity? Something really, really big. So I'll use 9,999. Okay, and then my mean, well, 0.14, my standard deviation, 0.0155. Okay, so again, what are these markers? Based on the raw data, we're saying, okay, well, this is the statistic that they're mentioning. And here, we're saying up to infinity. Okay, that 0.14, that's the mean, right, which is the same as the parameter that is stated with the standard deviation of 0.0155. So when I type that in, that's going to give me about 0.0001 as my probability. Let me just make sure that you're seeing what I see. So I'm going to type it in one more time. So here I'm doing normal CDF, and I'm saying from 0.2 to placeholder for infinity, I'm going to use 9,999, right? Something just really big. Here is my mean, 0.14, with this standard deviation, 0.0155. So I don't always have to convert to z-squares, right? I can use my mean and standard deviation for my raw data. So I'm seeing, oh, wow, that's really, really unlikely. That would be very, very, very unusual. And our threshold right now for saying what is unusual, what is not unusual, we're saying if it's less than 5%, it'd be unusual. So this would be very, very unusual. If I make this a percent, I'd say, well, I would expect this to play out in only 0.01% of samples. So if I write myself a summarizing statement, I can say, well, in only 0.01% of samples are we seeing this result. There are more than 20% Harley-Davidson owners. Right? So since we're seeing this only 0.01% of the time, it's super unusual. So this result is very unusual. Okay, and again, that threshold that we're setting, we're calling something unusual. We're saying if we're seeing something that's 5% or below. Okay, but we know that if we have something that's kind of on the border, it could really go either way. This one, it is abundantly clear, 0.01%. That would be super rare, super uncommon to see more than 20% Harley owners from our samples that are randomly picked of size 500. All right, I hope that helps just pull it all together and just solidify your understanding of sampling distributions for proportions. Have a good day.